Hello, and welcome to the Recreatus Podcast. This is a podcast on virtual heritage, the technologies used to enable virtual heritage projects, and the application of virtual heritage to support cultural heritage broadly. In this episode, we're going to take a look at the various platforms used to view virtual heritage projects in immersive 3D space, including virtual reality and augmented reality. While we often utilize traditional flat screens and monitors to view virtual heritage projects, we have seen increased use of virtual reality and augmented reality interfaces to view our representations of the past. Let's begin this discussion with a brief history of virtual reality and augmented reality. While there are various origins of images and representations that we can point to, let's start with the predecessor, the stereoscope. The stereoscope has been around since the 1830s and utilized two images of the same area from slightly different perspectives to imitate our binocular vision and to trick our mind into thinking it is perceiving one view in 3 dimensions. Many of us have used the modern commercial version of the stereoscope, the ViewMaster. This is a portable version of the stereoscope that utilizes stereo images on either side of a disc that can be viewed in a series of thematic images, or you can swap out the discs for endless content and enjoyment. In 1952, the Sensorama was created to engage multiple senses by utilizing the sense of smell, color vision, and sound, bringing a place or a thing to life. While this machine was bulky and essentially a small room or closet the size of a vending machine, it provided the user a more immersive experience. The inventor of the Sensorama followed it up just a few years later with what, even today, would be recognizable as a head-mounted display. In 1960, the Telesphere Mask offered a self-contained pair of television tubes for viewing stereo content. Throughout the 1950s and 60s, electronic devices improved, leading us to 1969, when the phrase artificial reality was coined. These developments through the 1960s and 70s represent a first wave of the visualization hardware that we would now refer to as virtual reality. As VR gained cultural and commercial interest in the 1980s and 1990s, new technologies such as the liquid crystal display helped to push the visual technologies, while peripherals for both controlling the experience and enhancing the immersion in the environments expanded the industry. As video games more commonly shared representations of cultural objects and landscapes in the 1990s and early 2000s, the concept of serious games saw the use of game engines and graphics in academia and nonprofit activities expand. The growth of software and graphics rendering during this time, such as increased graphic detail and resolution, as well as physics engines, set the stage for the technologies and capabilities we use today. In the 2010s, a new round of HMDs from Oculus, HTC, Sony, and others finally found the commercial success that previous attempts had not. These head-mounted displays can be found not only in universities and museums, but in homes across the world. They are the primary form factor for virtual reality currently. That said, there are other formats for viewing virtual reality content. Caves, or cave automatic virtual environments, have been around for decades and place the user within a physical space that combines projection with stereo glasses to give users a 3D immersive visual experience. Combined with speakers, these room-sized virtual environments are one of the few ways currently we have of shared VR experience. While VR has become a standard approach for viewing virtual heritage representations, there are projects that have expanded to use augmented reality, where virtual reality relies on showing the user a completely generated environment. Augmented reality overlays 3D graphical objects onto the real world. This allows users to see digital representations of the cultural objects within its real-world context, similar to the use of transparent physical displays that allow users to see the outlines of a building or other object as they look through the glass onto the landscape. There have been various attempts at hardware to support such augmented reality applications. However, the technology has not found a commercially viable approach just yet, beyond the use of smartphones and tablets as viewers for the content. There are several AR projects, such as Microsoft's HoloLens, that have supported business-to-business approaches and hardware that is currently in early development stages like Meta's Orion, but these augmented reality headsets and glasses have not yet seen the broad adoption of VR headsets. But it's likely that this is just around the corner. Looking at the code environments that make these virtual and augmented scenarios possible, the graphics and physics engines that once required a top of the line computer now have been scaled to run on mobile devices. This is thanks to a combination of the robust nature of modern phone and tablet processors, as well as the refinement of engines that run these applications. There are a number of mobile apps that allow you to explore, interact with, and experience cultural heritage objects and locations. The augmented apps can add additional historical significance to cultural locations by overlaying, for instance, paint on a statue where it's been worn away by age, or even revealing a lost fresco on a wall that is now bare. The point of these virtual and augmented experiences is to provide a sense of verisimilitude to the reproduction of cultural objects and landscapes. The Cambridge Dictionary suggests that verisimilitude describes, quote, the quality of seeming true or of having the appearance of being real, unquote. This appearance of being real increases the user's immersion in the scene. The immersive nature creates a greater connection between the viewer and the content being viewed. To build greater immersion, most VR and AR experiences allow the user to interact with the objects in the environment. However, one of the most difficult aspects to capture in VR and AR is the feeling of touch and the general feedback when interacting with the virtual environment. Haptics are defined by Merriam-Webster as, quote, the use of electronically or mechanically generated movement that a user experiences through the sense of touch as part of an interface, unquote. Devices that generate haptics are often discussed and described in literature on VR, but these devices are less commonly used than VR itself. Technologies such as haptic gloves and vests use various methods to generate a sense of touch for a user interacting with virtual objects. But these are becoming less common as many head-mounted displays do not require physical sensors to track the hands or the body while you're in a virtual environment, but instead simply use the head-mounted display's external cameras to track you. This is to reduce the need for tools such as controllers and data gloves so that really they're only needed for haptic purposes, not for control at this point. However, these visualization technologies are intended to support and share an understanding of virtual heritage. Technologies like those discussed are intended to immerse users in a cultural destination with realistic sounds and imagery. The combination of data, software, and hardware allows a place or space of cultural significance to be recreated and shared broadly. For instance, a festival can be represented through the sounds of a fire, traditional music, chants, along with a visual representation of the festival to make someone feel they are observing or even participating in the experience, even if they have never taken part in person. As we wrap up our discussion on the technologies, software, and hardware that allow us to have an immersive experience within virtual heritage, we have to say that this is an area where significant growth is expected. The development of virtual heritage projects hasn't changed dramatically over the decades, but the capabilities of these projects continue to increase as the effort needed to develop and distribute them has decreased. That isn't to suggest necessarily that it's easy to create a virtual heritage experience, but that what has been developed and what will be developed continues to get better as our access to new technologies grows and we can share them more broadly. Be sure to join us in the next episode as we continue our conversation about virtual heritage.